Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And in this short video, another video in our series of videos dealing with SPSS, we're going to concentrate on undertaking what's known as a chi-squared goodness of fit test. Okay, so I just have opened up SPSS 25 here. I've got a blank data set. You can see I'm in data view. If I go into variable view, I've defined two variables, dice roll outcome 1 and dice roll outcome 2. Both of them are scaled variables. Okay, and what I want to do in this test is I want to test to see whether a particular dice that I've rolled a certain number of times, whether there's evidence to suggest that the dice is unbiased. In other words, that the dice is rigged in some way. And I suppose to get this, just for this particular example, what I've done is I've gone into Excel. Okay, I've set up two distributions. Okay, the first distribution here, you can see it has two columns. Okay, two columns. We have the numbers 1 through to 6. They represent the face value on a typical six-sided die. And what I also have here is the probability of that face value occurring, which in this case is equal to 1 divided by 6. You have a 1 in 6 chance, which gives me the number 1.66666666 and so on, yeah? And it's rounded to a certain number of decimal places there. But basically this particular discrete frequency distribution is setting up the probabilities associated with rolling an unbiased fair die. I have a second distribution that I've created down here. And what I've done is I've assigned probabilities to face values, and all the face values from 1 through to, maybe I'll make this a little bit bigger, okay? All the face values from 1 through to 6 have a probability of occurring, and I've rigged this. I've set the probability for the first one to be 0.12 for the face value of a 1, and all the way through to the face value of 5, that they're all as equally likely as anything else. But I've set the probability of rolling a 6 as 0.4. In other words, you have a 40% chance of rolling a 6 with this particular die. And what I want to do is, so that I can actually run this chi-squared goodness of fit test, what I want to do is I want to generate some random data, and in particular I'm going to generate 30 observations from rolling this particular, first of all rolling the first die, okay, where everything is as equally likely, and then rolling the second die where the 6 has a likelihood of 40% of occurring. And the way I'm going to set up the data is I'm going to go into the data analysis tool pack, which I've turned on. So I have a data analysis tool pack in Excel, and I'm going to hit data analysis tool pack, and I'm going to ask for random number generation. And I'm going to hit OK on that. And what I have here is the distribution type that's going to be produced is a discrete distribution. I want to generate a single variable, and I want to generate 30 random numbers from that particular variable. But more importantly, I need to specify, I need to tell Excel the distribution associated with, the distribution that we're going to associate with this random number generator. And in this case, for my first variable, it's the unbiased distribution. So I'm just going to highlight the face values, 1 through to 6, and also their probabilities. So I'm going to highlight from this cell, which is D5, all the way down to cell E10, if I'm not mistaken, yes. And what I'm going to ask is, so there's the probabilities, the values and their probabilities input into Excel, and I'm also going to specify the output range to be in this data sheet, okay. And what I'm going to do is I'm going to output the values right here for dice 1, okay. And I'm going to hit OK, and what that's done is it's randomly rolled a die based off this particular distribution, and it's generated some outcomes. So I'm going to take that outcome set here, just copy it. I'm going to go back into SPSS. My first dice roll outcome, I'm going to paste them values in there. So you can see now that I have 30 observations here. And I'm just going to do the same thing. I'm just going to do the same thing for the second outcome, the second experiment of rolling a die 30 times, but this time generate numbers based off this probability distribution, which is the unbiased one. So it's the biased one, whereas the first one was the unbiased situation. And then we're going to run two tests in SPSS. So I'm going to go to data analysis, random number generator, but this time the probability distribution I'm going to specify is this distribution right here. So it's from 1 down to the 0.4. My output cells are going to be in the second dice outcome column, which is going to be right here, and I'm going to hit OK. And now what that's done is it's generated numbers based off rolling a dice that has this particular probability distribution associated with it. So I'm going to copy them. I'm going to go back into SPSS, and I'm going to set up my second variable. I'm going to put the values in here, and I'm going to hit Control V just to paste them in there, and now I'm ready to go. Okay, so I now have my two variables. So I'm going to do two chi-squared goodness of fit tests. Don't forget the null hypothesis associated with these distributions, okay, is that the data follows the specified distribution. The alternative hypothesis being that the data doesn't follow the specified distribution. So let's see how we tell SPSS how to compare the observations. Whoops, let me go back in here. What happened here? This is after dying on me. SPSS statistics quit unexpectedly. Okay, reopen, report it. No, I don't want to report it. Cancel that, don't send. Okay, let me open up SPSS here. Show reasons, no, options. Let me just open that up again. Okay, sorry, I don't know why that caved in. Hopefully this saved this for me. Just give that a second now just to open up. So my